In question 1, we have to express x squared plus 6x plus 2 in the form x plus a whole squared plus b. So to express x squared plus 6x plus 2 in the form, we'll first expand the form and write it as x squared plus 2ax plus a squared plus b. Now comparing the coefficients, on the left hand side, the coefficient of x is 6, and on the right hand side it is 2a. So 2a will be equals to 3. 2a will be equals to 6 and a will be equals to 3. The constant on the left hand side is 2 and on the right hand side it is a squared plus b. So we can write a squared plus b will be equals to positive 2. As we already have the value of a, which is 3, so we can write it as 3 squared plus b equals to 2. So b will be is equals to 2 minus 9, which is equals to minus 7. So we can write the expression as x plus 3 whole squared minus 7. In part 2, it says, hence or otherwise find the set of values of x for which x squared plus 6x plus 2 is greater than 9. So in the first step, what we can do is, we can first we can write x squared plus 6x plus 2 as x plus 3 whole squared minus 7. And this is greater than 9. Taking 7 on the other side, we'll get x plus 3 whole squared, which is equals to 7 plus 9, so that will become 16. Taking the square root on both the sides, so this will be x plus 3 will be greater than square root of 16. As square root of 16 can be plus and minus 4, so first we'll find the values of x. So this will be plus and minus 4. So first taking x plus 3 as equals to 4. So the first value of x will be, so x plus 3 equals to 4. So x will be equals to 4 minus 3, which is 1. And if we take x is equals, x plus 3 equals to minus 4. So x will be equals to minus 4 minus 3, which is minus 7. Now to give the correct inequality sign, we'll make this on a x-axis, and as one of the x values is 1 and the other is 7. And as the equations was x plus 3 whole squared minus 7 is greater than 9, so it means that if you bring the 9 on this side and simplified it, the equation would have been for greater than 0. So for the values of x for which this whole equation is greater than 0, we'll have to move towards the right from x equals to 1 and move towards left from x equals to minus 7. So the final answer will be x is greater than 1 and x is less than minus 7. In question 2, we have to find the term independent of x in the expansion of 2x plus 1 upon 2x cubed to the power 8. The expansion formula that we use is a for a plus b to the power n is a power n plus nc1 a power n minus 1 b to the power 1 plus nc2 a to the power n minus 2 b to the power 2 and so on. Now we can either guess which of these terms to take, which will give us a term independent of x, or we can find this value 1, 2, or 3 that will give us a term independent of x. Now we use the formula NCR a to the power n minus r b to the power r, that will give us the power, which will give us a term independent of x, which basically means x to the power 0. Now as we are just trying to find the power of x, so we can just write it as 8CR. For a, the power of x is 1, so this will be x to the power 8 minus r. And for b, the power of x is minus 3, so this will be x to the power minus 3 to the power r equals to x to the power 0. Now just comparing the powers of x, so this will become 8 minus r minus 3r equals to x to the power 0. So this will become 8 minus 4r equals to 0. Solving this will be equal, 8 will be equals to 4r, so r will be equals to 2. Now applying 8c2, so this will become 8c2 a to the power n minus 2, so that will become 2x to the power 8 minus 2 into 1 upon 2x cube to the power 2. So 8c2, if we substitute this in the calculator, so 8c2 is equals to 28, so this will become 28 into, so 2 to the power 6, so 2 power 6 is 64, so this will be 64 x to the power 6. and this will be 1 upon 2 square. So 2 square is 4, and x to the power x cube whole square will be x to the power 6. x6 and x6 will cancel out. 28 multiplied by 64 divided by 4 will be equals to 448. So the term independent of x will be 448. In question 3, in the diagram, OCA and ODB are radii of the circle with center O and radius 2r. Angle AOB is alpha radians. CD and AB are arcs of circle with center O and radius radii 2r and r respectively. The perimeter of the shaded region is ABD. Region ABDC is 4.4r. We have to find the value of theta. Now for the perimeter of the shaded region, we'll be adding the two arcs. So we'll be adding arc length CD plus the arc length of AB plus, so AC will be R and BD will also be R. Now to find the arc length of CD, so arc length CD will be given by the formula R theta. Now the value of R will be taken as R and theta is alpha, so we can write it as R alpha, and the arc length for AB will be given by the radius, so radius will be 2R and the angle is alpha. So now substituting this into the formula for the perimeter, so that will become arc CD is R alpha, arc AB is 2R alpha, and R plus R will become 2R, and it's given that the perimeter is equals to 4.4R, so we can equate it to 4.4R. Taking R common, we'll get alpha plus 2 alpha plus 2 will be equals to 4.4R. R and R will cancel out. So 4.4 will be equals to alpha plus alpha, which is 3 alpha plus 2. So 3 alpha will be equals to 4.4 minus 2. So alpha will be equals to 2.4 divided by 3. So 2.4 divided by 3, alpha will be equals to 0.8. In part 2, it says that it is given that the area of the shaded region is 30. We have to find the value of R. Now for the shaded region, first we can find the area of the sector OAB and then subtract it from the area of sector OCD. So for part 2, when we are finding the area of shaded region, so the area of shaded region will be equals to area of arc, area of sector OAB. So area of OAB minus the area of the sector, which is OCD. So first finding the area of OAB. The formula for area of a sector is given by area is 1 upon 2 r squared theta. So we know that the radius is 2r, so this will be 1 upon 2 into 2r whole squared, and alpha or theta in this case is 0.8. So this will become 4r squared into 0.8 upon 2. Simplifying this, we'll get 2 into 0.8, which is 1.6 r squared. Now finding the area of sector OCD. So area of sector OCD will be equals to 1 upon 2 r squared theta. So r is r, so this will become 1 upon 2 r squared into 0.8. 1 upon 2 into 0.8, that will be 0. Divided by 2. So 0.2 divided by 2 is 0.4. So the area of sector OCD will be 0.4 r squared. Now, as the area of the shaded region was 30, it was given the question that the area of shaded region is 30. So we'll subtract 1.6 r squared. So the area of shaded region is equals to 1.6 r squared minus 0.4 r squared, and that is equals to 30. So 30 is equals to 1.6 minus 0.4 is 1.2 r squared. 30 divided by 1.2 is equals to 25. So r squared will be equals to 25. Taking the square root of 25, r will be equals to 5 centimeters. In question 4, C is the midpoint of the line joining A and B. The line through C perpendicular to AB crosses the y-axis at D. In part 1, we have to find the equation of the line CD, giving our answer in the form y equals to mx plus c. Now, to find the equation of any line, we need the point and the gradient of the line. So, as C is the midpoint of AB and we have to find the equation of the line CD. So, in the first part, finding the midpoint of AB, that will be equals to x1 plus x2. So, that will be 14 plus minus 6 upon 2, comma, minus 7 plus 3 upon 2. So 14 minus 6 is 8. 8 divided by 2 will be 4. Minus 7 plus 3 is minus 4, which divided by 2 will become minus 2. So 4 comma minus 2 are the coordinates of C, as it is a midpoint of AB. And to find the gradient of the line, as the line is perpendicular to AB, first we'll find the gradient of AB. That will be y2 minus y1 divided by x2. So x2 will be minus 6 minus x1, which is 14. So 3 plus 7 will be equals to 10, minus 6 minus 14 will be equals to minus 20. So the gradient of AB will be minus 1 upon 2. As it is perpendicular to CD, so the gradient of CD will be equals to positive 2. Now finding the equation of the line. So equation of a line is given by the formula y minus y1 equals to m into x minus x1. So as y1 is minus 2, so this will be y minus minus 2 is equals to m, which is the gradient, 2 into x minus 4. Simplifying this, we'll get y plus 2 is equals to 2x minus 8. So y will be equals to 2x minus 8 minus 2. So the final equation will be y equals to 2x minus 10. Now in part 2, it says find the distance AD. Now D was the point, D was on the y-axis and it was on the line through C, which was perpendicular to AB. So we already have the equation of CD, which was y equals to 2x minus 10. So in the first step, finding the point D, we know that the equation is y equals to 2x minus 10, and D has coordinates 0, comma y, as it is crossing the y-axis. So substituting x equals to 0, the value of y will be equals to minus 10. So the coordinates of D will be 0 and minus 10. Now finding the distance CD. So finding the distance AD, A is 14 and minus 7. So A is 14 and minus 7. Applying the distance formula for AD, which is x2 minus x1 whole squared. So that will become 0 minus 14. So 0 minus 14 whole squared plus y2 minus y1. So that will be minus 10 minus minus 7 whole squared. 14 whole squared. So 0 minus 14 is a minus 14 whole squared, which is 196. And this will become minus 10 plus 7. So minus 10 plus 7 will be minus 3 whole squared, which is equals to, so 196 plus 9 will be equals to square root of 205. So the distance AD will be square root of 205. If you want to give this in decimal form, so that will be equals to 14.31. But as we have to give our answer to 3 significant figures, so the final answer will be 14.3. So we can give our answer as 14.3, or we can leave our answer in the form square root of 205. Both answers will be marked correct. In question 5, the sum of the first and second terms of a geometric progression is 50, and the sum of the second and third term is 30. We have to find the sum to infinity. Now, the sum to infinity is given by the formula a divided by 1 minus r. So we need to find the value of a and r and then find the sum to infinity. Now, as the sum of the first and second term of a geometric progression is 50, so the nth term of a geometric progression is given by a r to the power n minus 1. For the second term, it will be a r to the power 2 minus 1. So that will be equals to a r. So the second term is a r. We know that the first term will be equals to a, and the third term will be equals to, so third term will be equals to a r to the power 3 minus 1, which is equals to a r squared. Now, as the sum of the first and the second terms is 50, so we can make an equation. So that will be a plus a r will be equals to 50. And the sum of the second and third term is 30. So the other equation will be AR plus the third term, the second term plus the third term will be equals to 30. Now taking a common from the first equation, we can write it as a bracket 1 plus r equals to 50. So a will be equals to 50 upon 1 minus r, 1 plus r. Now substituting this value into the second equation, in place of a, we'll substitute 50 upon 1 plus r. So this will become 50 upon 1 plus r multiplied by r plus 50 upon 1 plus r multiplied by r squared equals to 30. Now, as 1 plus r is a common denominator, we can cross multiply it with 30. So we'll get 50r plus 50r squared will be equals to 30 into 1 plus r. Expanding and simplifying, we'll get 50r plus 50r squared will be equals to 30 plus 30r. Bringing the 30 and 30r on the left hand side, so we'll get 50r squared plus 50r minus 30r will become a plus 20r, and this 30 will come on this side and become a minus 30 equals to 0. Dividing the equation by 10, simplifying this, we get 5r squared plus 2r minus 3 equals to 0. Factorizing this, we get 5r squared plus 5r minus 3r minus 3 equals to 0. Taking 5r common, so this will be r plus 1, and taking 3 common, we'll get r plus 1. Simplifying this, we'll get 5r minus 3 and r plus 1 equals to 0. So the two values of r will be 3 upon 5 and r will be equals to minus 1. Now, as r cannot be negative 1, so if in that case, all the terms would have been the same with opposite signs, which means that the value of r will be equals to 3 upon 5. So once we have the value of r, we can find the value of a, as a was equals to 50 upon 1 plus r. So we can write a will be equals to 50 upon 1 plus 3 upon 5. So that will be equals to 50 divided by, so taking the LCM, that will become 5 plus 3, 8 upon 5, or 50 will multiply by 5 and become 125 upon 8. Once we have the value of a and r, now we can apply it to the formula for sum. So sum to infinity will be equals to a, which is 125 upon 8, divided by 1 minus r, which will be 1 minus 3 upon 5. Simplifying this, we'll get 125 upon 8 divided by, so 5 minus 3 will become 2 upon 5. Now, to simplify this fraction, we can directly substitute it into the calculator, or we can just write it as 125 upon 8 divided by 2 upon 5. And when we bring in the multiplication sign, so this will become 125 upon 8 into 5 upon 2. So this will become 5 upon 2. And this was, so 5 plus 3 was 8, 125 upon 8. So the value of a was 125 upon 8, and this was 5 minus 3, 2 upon 5. So a was, so there's a small mistake over here. The value of a was 125 upon 4, as 50 into 5 was 250. So this was 250 upon 8, or it should have been 125 upon 4. So over here, this should have been a 4 up here. So this would be 125 upon 4. Substituting 4 up here, so this will become 125 upon 4 multiplied by 5 upon 2. So 125 into 5 is 625, and 4 multiplied by 2 will be 8. So the final answer for the sum to infinity will be 625 upon 8. In question 6, part 1, we have to show that cos to the power 4x is an identity of 1 minus 2 sine square x plus sine power 4x. So cos to the power 4x, if you want to prove it as an identity of 1 minus 2 sine square plus sine 4x, first we can write it as cos square of x whole squared. Now cos square of x is an identity of 1 minus sine squared. So as sine squared x plus cos squared x is equals to 1. So cos squared x can be written as 1 minus sine squared of x. So in place of cos squared, we can write 1 minus sine squared, and this will be whole squared. Now expanding using the expansion formula, a squared minus 2ab plus b squared. So this will become 1 minus 2 sine squared plus sine squared whole square. So that will become sine power x, sine to the power 4. So we can write it as 1 minus 2 sine square x plus sine to the power 4x. In part 2, it says, hence or otherwise solve the equation 8 sine 4x plus cos 4x is equals to 2 cos square of x. Now, in place of cos 4 of x, we can write it as 1 minus 2 sine square plus sine 4x. So this will become 8 sine to the power 4x plus, in place of cos 4x, we can write 1 minus 2 sine squared x plus sine to the power 4x. And this is equals to 2 cos squared of x. So this will become 2 into 1 minus sine squared of x. Simplifying this, we'll get 8 sine to the power 4 plus 1 minus 2 sine squared plus sine to the power 4 is equals to 2 minus 2 sine squared. Minus 2 sine squared and minus 2 sine squared will both cancel out. 8 sine to the power 4 plus sine to the power 4 will be 9 sine to the power 4, and 2 minus 1 will become 1. So sine to the power 4 will be equals to 1 upon 9. Now, taking the fourth root of 1 upon 9, so that will be equals to sine. So sine x will be equals to 1 upon 9 and x will be equals to sine inverse of square root of 1 upon 9 or fourth root of 1 upon 9. So finding that, that will be equals to 1 divided by 9, square root of the answer. That will be equals to, so square root of 9 and then 1 divided by answer and then shift sine inverse. So this will be 0.577. So x will be equals to sine inverse of 0.577, which is equals to 30. So shift sine inverse answer, that will be equals to 35.23. So that will be equals to 35.23. We can take it as 35.2 degrees. Just for correction, so if I take the square root of 9 and then take square root of the answer again and 1 divided by answer and shift sign inverse, so that is 35.26, not 23, as the decimal places are important. So any mistake will result in a loss of marks. So the final answer for this will be 35.3 degrees. Now, as this square root or the power 4 value can give plus and minus sign both, and 35.3 is a basic angle. So we'll make this basic angle in all the 4 quadrants, as it can be both a positive and a negative value. So making 35.3 in the first quadrant, we'll also make it in the second quadrant and in the third and the fourth as well. Once we have made the basic angle in these quadrants, we'll find the values of x by taking the angles anti-clockwise from the x-axis. So the first value of x will be equal to 35.3 degrees. The second value will be 180 minus 35.3. So 180 minus 35.3 is 144.7 degrees. So this was 144.7 is this angle. And then the next angle will be 180 plus 35.3. So 180 plus 35.3 is 215.3 degrees. And the last angle will be the angle in the fourth quadrant, which is 360 minus 35.3, which is equal to 324.7 degrees. So these will be the 4 values of x. In question 7, the diagram shows part of the curves of y equals to 2x minus 1 whole squared and y squared equals to 1 minus 2x intersecting at the points A and B. In part 1, we have to state the coordinates of A. Now, as A lies on the curve, lies on both the curves and it is at the x-axis, so we can use either of the curves equation, y squared equals to, let's say using y squared equals to 1 minus 2x. Substituting y equals to 0 as it is on the x-axis, so it will be 0 equals to 1 minus 2x. So x will be equals to 1 upon 2. So the coordinates of A will be 1 upon 2 comma 0. In part 2, we have to find the area of the shaded region, showing all the necessary working. Now, to find the area of the shaded region, we'll first have to find the area under the curve with the equation y squared is equals to 1 minus 2x, which will give us this complete area. Then we'll find the area under the curve of the curve with equation A, which will give us the area in black. Subtracting these two areas will give us the area of the shaded region. Now, first using the equation, so using finding the area under the graph of the equation y square equals to 1 minus 2x. So we can first write the equation as y equals to 1 minus 2x to the power 1 upon 2, as taking the square root on both the sides. Now to find the area, we will first integrate this equation, and the limits will be, as the point A has coordinates 1 upon 2, and this is the origin where the x coordinate is 0. So the limits will be 1 upon 2 and 0. And the equation is 1 upon 2x to the power 1 upon 2. So integrating, we'll get 1 minus 2x and increasing the power by 1. So that will become 3 upon 2. Dividing by the new power, which is 3 upon 2. And also multiplying it with the derivative of 1 minus 2x, which is minus 2. So this will simplify to become minus 1 upon 3 into 1 minus 2x to the power 3 upon 2. Once we have done the integration, now we can apply the limits, which is 1 upon 2 and 0. So substituting x equals to 1 upon 2, we'll get 1 minus 2 into 1 upon 2 to the power 3 upon 2. And we'll subtract it from the value where x is equals to 0. So this will become minus 1 upon 3 into 1 minus 2 into 0 to the power 3 upon 2. So 1, 2 and 2 will cancel out. 1 minus 1 is a 0. So this whole term will become a 0. And this will become, so minus 1 upon 3 will multiply it by 1, as 2 times 0 is 0 and 1 to the power 3 upon 2 is 1. So this will become 0 plus 1 upon 3. So the area under the curve with the equation 1 minus 2x to the power half is 1 upon 3. Now finding the area under the curve with the equation y equals to 2x minus 1 whole square. So that will be equals to, again, the limits will be 1 upon 2 and 0. The equation is 2x minus 1 whole squared. So integrating 2x minus 1, that will become 2x minus 1 to the power 3 upon 3. And we also multiplied with the derivative of 2x minus 1, which is 2. So this will become 2x minus 1 whole cube divided by 6. Now, once we have integrated, now we can apply the limits, which are 1 upon 2 and 0. So first substituting x equals to 1 upon 2, this will become 2 into 1 upon 2 minus 1 upon 6 whole cube. And then subtracting it from the lower limit, which is 0. So that will become 2 into 0 minus 1 upon 6. And this is a whole cube up here. So 2 and 2 will cancel out. 1 minus 1 is a 0. So 0 divided by 6 will be 0 minus, and this will become, so minus 1 whole cube is minus 1, as 2 times 0 is 0. So this will be minus 1 upon 6. So 0 minus minus 1 upon 6 will become a plus 1 upon 6. Once we have the area of both the area under the curve of both the regions, then we can subtract the two areas to find the shaded region. So the area of the shaded region will be equals to 1 upon 3 minus 1 upon 6. Taking the LCM, this will become, so this will multiply by 2 and this will multiply by 2. So this will be 2 minus 1. So the final answer for the area of the shaded region will be 1 upon 6. In question 8, functions f and g are defined by f of x is 4 upon x minus 2, g of x is 4 upon 5x plus 2. In part 1, we have to find and simplify an expression for fg of x and state the range of fg. Now, to find an expression for fg of x, in the function f, in place of x, we'll replace it with the function g. So the function g is 4 upon 5x plus 2, and this will be minus 2. Now the 5x plus 2 will go into the numerator and multiply with 4. So that will become 4 into 5x plus 2 divided by 4 minus 2. So 4 and 4 will cancel out. This will become 5x plus 2 minus 2. So 5x plus 2 minus 2, the 2 and 2 will cancel out. So f g of x will be equals to 5x. Now to find the range of fg, As we know that for g of x, the values of x has to be greater than or equals to 0. So when we substitute the value x equals to 0, fg of x will be equals to 0. And any other value that we substitute, the value will always be greater than 0. So the range of fg of x will be greater than or equals to 0. In part 2, it says find an expression for g inverse and state the domain of g inverse. Now the function g of x was equals to 4 upon 5x plus 2. To find the inverse function, we'll first write y in place of g of x. Then exchanging the values of x and y, this will be x equals to 4 upon 5y plus 2. Cross multiplying, we'll get 5xy plus 2x equals to 4. And now making y the subject, so this will become 5xy equals to 4 minus 2x. So y will be equals to 4 minus 2x upon 5x. So we can write that the g inverse function will be equals to 4 minus 2x upon 5x. Now, as we also had to state the domain of g inverse, we know that for a function, the range of the function is equal to the domain of the inverse function. Now, if you look at the function g of x, so g of x was 4 upon 5x plus 2. And the values of x were greater than or equal to 0. So if you can find the range of g inverse, that will be equal to the domain. If you find the range of g, that will be the same as the domain of g inverse. Now, when we are finding the range of g of x, initially we can substitute x equals to 0. So that will be equals to 4 upon 2. So g of x will be equals to 2. Now, any value of x greater than 0 will give us a value less than 2, as if we add any number. So let's say, let's take x equals to 1 up here. So that will become 5 into 1 plus 2. That will be 5 plus 2, which is 4 upon 7. And this is less than 2. However, whatever value we take up here, the value of g of x will never reach 0. However, it will always be less than 2. So we can say that the range of g of x will be greater than 0 and less than or equals to 2. As the range of g of x is greater than 0 and less than equals to 2, it means that the domain for f inverse will be the same. So the domain for for g inverse of x in this case, so the domain for g inverse of x will be x is greater than 0 and less than or equals to 2. In question 10, a curve has equation y equals to f of x, and it is given that f dash or or the derivative of f of x is 3x to the power half minus 2x to the power minus half. The point A is the only point on the curve at which the gradient is minus 1. In part 1, we have to find the x coordinate of A. Now we know that the gradient is minus 1, or we can say that that f dash of x is equals to minus 1. So we can write the expression of f dash of x, which is 3x to the power half minus 2 upon x to the power half equals to minus 1. Taking the LCM, so the LCM will be x to the power 1 upon 2. X to the power half multiplied by x to the power half, that will become 3x minus 2 equals to minus 1. Cross multiplying, we'll get 3x minus 2 is equals to negative x to the power half. Now to solve this equation, we can whole square both the sides, or we can use a substitution in place of x. So if we whole square both the sides, so we'll get this as 9x squared minus, so this will be 2 times 2, 4 times 3, which is 12x. So this will become minus 12x plus 4 is equals to, so minus x, so half 1 upon 2 to the power whole square will become a plus x. Taking this x on the left hand side, that will become 9x squared minus 13x plus 4 equals to 0. Now factorizing using middle term breaking, we get 9x squared minus 9x minus 4x plus 4 equals to 0. Taking 9x common, this will be x minus 1. Taking 4 common, that will be x minus 1 equals to 0. Simplifying, we'll get 9x minus 4 and x minus 1 equals to 0. So x will be equals to 1 and x will be equals to 4 upon 9. Now, as if we take x equals to 1 up here, so this will become 3 minus 2 upon 1, which will not be equals to minus 1, as 3 minus 2 is a positive 1. It means that the only value of x that we can take will be 4 upon 9. So the x coordinate of A will be 4 upon 9. In part 2, it says given that the curve also passes through the point 4, comma 10, we have to find the y coordinate of A, giving our answer as a fraction. Now to find the y coordinate of A, we first need to find the equation of the function f of x. So we know that the derivative f dash of x is given by, so f dash of x is equals to 3x to the power half minus 2x to the power minus 1 upon 2. So taking the integral on both the sides, so in taking the integral of f dash of x, that will be f of x is equals to, so the power will increase by 1. So 1 upon 2 plus 1 is 3 upon 2. And we'll divide by the new power, which is 3 upon 2, minus increasing the power by 1, that will become 1 upon 2. And this will also divide by 1 upon 2. And we'll add a constant over here. Simplifying this, we can write this as f of x will be equals to, so 3 and 3 will cancel. The 2 will go in the numerator. So that will become 2x to the power 3 upon 2 minus 4x to the power 1 upon 2 plus c. Now to find the value of c, it says that the curve passes through the points 4, comma 10. Now as the curve passes through the points 4, comma 10, we can write 10 in place of f of x, and this will be 2 into 2 to the power 3 upon 2 minus 4 into 2 to the power 1 upon 2 plus c. So this will be 10 is equals to 2 into, so this is x equals to 4. So we'll have to substitute x equals to 4 up here. So this will be 4 to the power 3 upon 2. So square root of 4 is 2 and 2 cube is 8 minus the square root of 4 is 2. So that will be 4 into 2 plus c. So c will be equals to 10 is equals to 16 minus 8 plus c. So 16 minus 8 is 8 and 10 minus 8 will be equals to c. So the value of c will be equals to 2. Now, once we have the value of c, we can write first the function as f of x will be equals to 2x to the power 3 upon 2 minus 4x to the power 1 upon 2 plus 2. And now to find the y coordinate of A, we'll substitute the x coordinate, which you found in the previous part, which was 4 upon 9. So substituting x as 4 upon 9. So this will be 2 into 4 upon 9 to the power 3 upon 2 minus 4 into 4 upon 9 to the power 1 upon 2 plus 2. We can substitute this completely in the calculator to get the y value or the value of the function when x is 4 upon 9. Or the square root of 4 is 2 and 2 cube is 8. The square root of 9 is 3 and 3 cube is 27. Minus 4 into the square root of 4 is 2. The square root of 9 is 3 plus 2. So this will become 16 upon 27 minus, so this will be 2 upon 3 minus 8 upon 3 plus 2. Taking the LCM and simplifying, this will become 16 minus, so this will multiply by 9 and this will also multiply by 9. So this will be 16 minus 72. And this is, the denominator is 1, so this will multiply by 27. So this will be plus 54 upon 27. So 16 plus 54 is 70. 70 minus 2 is minus 2. So the value of the function of f of x or the value of y will be minus 2 upon 27. So we can say that the y coordinate for A will be minus 2 upon 27. In question 11, the point P3, 5 lies on the curve y equals to 1 upon x minus 1 minus 9 upon x minus 5. In part 1, we have to find the x coordinate of the point where the normal to the curve at P intersects the x-axis. Now to find the x coordinate of the point where the normal crosses the x-axis, we first need the equation of the normal, and then we can substitute y equals to 0 to find the x coordinate. Now to find the equation of the normal, we need the gradient in the first case. So to find the gradient, first we'll find the dy dx of the function. We'll first write it as x minus 1 to the power minus 1 minus 9, and this will become x minus 5 to the power minus 1. Finding the gradient dy dx, which will give us the gradient of the tangent. So minus 1 will multiply with the coefficient. So this will become minus x minus 1 to the power minus 2. Minus 1 into minus 9 is a plus 9, and this will become x minus 5 to the power minus 2. We can simplify it and write it as minus 1 upon x minus 1 whole squared plus 9 upon x minus 5 whole squared. Now, as the point P has x coordinate 3, we can substitute x equals to 3 up here. So this will become minus 1 upon 3 minus 1 whole squared plus 9 upon 3 minus 5 whole squared. Simplifying this, this will become minus 1 upon 2 squared, which is 4, plus 9 upon 3 minus 5 whole squared, which will be 4. So minus 1 plus 9 is 8, 8 upon 4. So the gradient will be 2. So the gradient of the tangent is 2, which means that the gradient of the normal will be a negative reciprocal, which is minus 1 upon 2. Once we have the gradient and we know that the normal passes through the point 3, 5. So the point is P, which is 3, 5. We can now make the equation using y minus y1. So y1 will be 5 equals to m, which is minus 1 upon 2 into x minus x1, which is 3. Now to find the x coordinate at where the normal crosses the x-axis. So we know at the x-axis, the y coordinate will be 0. So we'll substitute y equals to 0 into the equation. We'll get 0 minus 5 is equals to minus 1 upon 2x plus 3 upon 2, multiplying half with x and minus 3. Simplifying, we'll get minus 5 minus 3 upon 2 is equals to negative 1 upon 2x. Taking the LCM, this will become minus 10 minus 3 upon 2 is equals to negative 1 upon 2x. This will become minus 13 upon 2 is equals to negative 1 upon 2x. The negatives will cancel and the 2 and 2 will cancel. So the x coordinate will be equals to 13. In part 2, it says find the x coordinate of each of the stationary point on the curve and determine the nature of each stationary point, justifying your answer. So for stationary points, we'll have to put the dy dx equals to 0 and then find the values of x. So the dy dx is minus 1 upon x minus 1 whole squared. So in the first step, we'll write it as dy dx is equals to minus, which is x minus bracket x minus 1 to the power minus 2 and plus 9 into x minus 5 to the power minus 2. So this is plus 9 into x minus 5 to the power minus 2. Putting it equals to 0, we'll get 0 is equals to minus x minus 1 to the power minus 2 plus 9 into x minus 5 to the power minus 2. Taking x minus 1 to the power minus 2 on the left hand side, this will become x minus 1 to the power minus 2 plus, which is equals to 9 into x minus 5 to the power minus 2. We can now bring this in the denominator and write it as 1 upon x minus 1 whole squared, and this is equals to 9 upon x minus 5 whole squared. To get rid of the squares, we can directly square root both the sides. So we'll get 1 upon x minus 1, and this will be 3 upon x minus 5. Now, as a square root can contain both a positive or negative value, so we can include a positive negative sign with one of the sides. So let's say we can take plus, x minus 1 as a plus minus. We can do the same with x minus 5. It will give us the same answer. So to find the first value of x, we can take it as 1 upon x minus 1 is equals to 3 upon x minus 5. And for the second value of x, we can take it as minus 1 upon negative x minus 1, which is equals to 3 upon x minus 5. Cross multiplying, we'll get x minus 5 is equals to 3x minus 1. Taking the x on this side, we'll get minus 5 plus 1 is equals to 3x minus x. So minus 5 plus 1 is a minus 4, and this will become 3x. So this will become minus 5 plus 3x minus x, which is 2x. So x will be equals to minus 2. And there was already a negative sign over here, which I missed. So this would multiply. So there is a small correction that needs to be done over here, as there was a negative sign already over here. So this will become 1 upon x minus 1, and this is 3 upon x minus 5. Cross multiplying it with 1, this will be 3x minus 3 is equals to x minus 5. So 3x minus x will become a 2x, and this will be minus 5 plus 3. So the value of x will be 2x is equals to minus 2, and x will be equals to minus 1. And then this will become minus x plus 1. So we can write it as minus x plus 1 is equals to 3 upon x minus 5. Cross multiplying, we'll get x minus 5 is equals to minus 3x plus 3. Now taking 3x on this side, we'll get x plus 3x is equals to 3 plus 5. So 4x will be equals to 8, and x will be equals to 2. So the two values of x are x equals to 2 and x equals to minus 1. Now, as we will also have to find the nature of each of the stationary points, so we'll first have to find the double derivative. Finding the double derivative, we'll have to differentiate the function for dy dx again. Now, the function for dy dx was minus x minus 1 whole squared to the power minus 2, and this was a plus 9 into x minus 5 to the power minus 2. Now, differentiating it again, we'll get, so minus 2 will multiply by minus 1, that will become a plus 2 into x minus 1 to the power minus 3. Minus 2 into 9 will become a minus 18, and this will be x minus 5. Minus 2 minus 1 will be minus 3. So the expression for d square y upon dx square is 2 into x minus 1 to the power minus 3, which we can now write it as 2 upon x minus 1 whole cube minus 18 upon x minus 5 whole cube. Now to find the nature, we'll substitute the two values of x individually, taking x equals to minus 1. So when x is equals to minus 1, this will be 2 upon minus 1 whole cube minus 18 upon, so the value of x was minus 1, so this will become minus 1 minus 6 whole cube. So this will be equals to 2 upon minus 2 whole cube, which is minus 8, and this will be minus 18 upon, so this will become minus 6 whole cube. So minus 6 whole cube will be a minus 216, or we can write it as minus 1 upon 4 plus 18 upon 216. So 18 divided by 216 plus, so and subtracting it from 0.25, we'll get a negative 0.176. Now, as it is a negative value, so as we are getting negative 0.176, this means that when x is equals to minus 1, as this is less than 0, this will be a maximum point. And now substituting x equals to 2 into the same expression, we'll get, so when x is equals to 2, so this will be 2 upon 2 minus 1 whole cube minus 18 upon 2 minus 5 whole cube. So this will be 2 upon 1 cube, which will be 2, and this will be 18 upon minus 3 whole cube, which will be minus 27, and this negative will make it a plus. So this will become 2 plus 18 upon 27. Now, as this value will be greater than 0, so we can say that when x is equals to 2, it will be a minimum point.